Good evening, everyone. I hope everyone's having a lovely evening. So, it is a great honor to be able to speak to you guys today. Just a little bit about me. My name is Jessica Randall. I am a Women Tech Maker Ambassador, crowdsource influencer, GDG co-organizer, and a Girl Code Ambassador. And I'm going to give a brief introduction to machine learning. And the title of my talk is Unlocking the Power of Machine Learning. So the agenda for today is I'm going to give a brief intro to ML, discuss the different types of machine learning tasks, give a brief overview of what the workflow looks like, because it's different for every person who builds a machine learning model, discuss the challenges that you might have with your machine learning model, and then we're going to dive into the Teachable Machine. Okay, so what is machine learning? So basically, it's a modern software development technique that falls under AI, so it's a subset of artificial intelligence. It allows computers to solve problems using real-world data to solve real-world problems. And computers can learn and improve from experience without explicit coding. So I have some examples of machine learning. So one example is, have you ever heard of recommendation systems? So when you go into Netflix and then they build a machine learning algorithm around what you pick to watch and what you add to your list, and that's how they come up with recommendations for you. The same applies to Disney Plus, also to music applications like Spotify, Apple Music, and they use the same type of machine learning algorithm. Also speech recognition, so like Siri, Alexa, and Google Assistant. So I know on Google Assistant there's a setting where you can say, do not listen to anyone else's voice. I tried it, so my brother tried to give it demands, and then it didn't execute them because it only recognizes my voice. So there are three different types of machine learning tasks. You have supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is when you give your machine learning labeled data, or you tell your machine learning model this is a picture of a cat. They will recognize it as a picture of a cat. So you use the labeled data to make new predictions on new unseen data. Then you have unsupervised learning, where you don't work with labeled data. You don't give it a label. So it's unlabeled data, and you use it to find patterns and structure. And then the last one is reinforcement learning, which is you learn through trial and error to see, okay, this is what you want me to do, this is what you don't want me to do. So we're going to go through some examples. So an example of supervised learning is, when you go onto your email and you look at spam and you see some email addresses are sent to spam. So this is an example of supervised learning. So usually when you work for a company or organization, they build all those email addresses with that specific extension, like @myuwc is a UWC domain email. So it will recognize any UWC email. But then it won't recognize any other email, and it sends it automatically to spam. So that's an example of labeled data, which is supervised learning. And then example of unsupervised learning is when you have labels of things, but they can be combinations of things. So an example is you can cluster similar customers based on their shopping habits, which is not really defined because people have many different shopping habits, or there could be combinations of it that is not directly labeled. So that's why we look at it as an unlabeled set of data. And then last but not least is reinforcement learning. So it's, I don't know if you guys have heard of AWS Deep Learning Racer. So basically you get like a car and you build a Python script and you tell it you either want it to execute like zigzag, you want it to stay within the lines, or you want it to not cross over the boundary lines. And then if it does do that, then the program will reset and then you get points deducted off it. But if you stay on the track and you fit within what you wanted to do, then you get a reward. So like they train by constantly going through the path all the time. So like they'll go through the path and then go off the track and then they'll start again, but then realize they need to swerve this way or swerve that way. And that's an example of reinforcement learning. Another example is training a robot to navigate a maze by giving it rewards for what you want it to do, and then penalizing it if it hits any walls and stuff. So you want it to go smoothly through the maze. So I'm going to give a brief overview of a machine learning workflow, just because it differs to every individual. So these are numbers 1 to 6. Sorry for the misnumber print. But first what you do is you collect your data and you gather it and you start preparing it for using it in your machine learning model. And once you have all your data, then you go to the pre-processing part of it. You clean it, you transform it, you make sure that it's good quality data to feed your machine learning model. And then you'll split your data set randomly so that you avoid bias. Most people split 80% 20, so they train on 80% of the data and they test on 20% of the data. And then you do your model selection. So you choose a machine learning type of model based on the type of problem that you have. It differs, so sometimes you might use, it's a really simple problem that you want to solve, then you'll use like a linear regression model, or if it's something a bit more complicated, then you'll use neural network, which is a bit more complex. And then you will train your model by feeding it the data that you have collected, and when it trains on this data set, it learns how to be more accurate and improve its detecting skills. And then you have what you call model evaluation. So you assess the performance of your machine learning model. You give it a validation set to test if it does actually do what it needs to do. This is really important because sometimes you could build a machine learning model and you think it does what it's supposed to do, and then only in the last step it does what it's supposed to do, or only in the last step you see that it doesn't do what it's supposed to do, and then it's like you have to start all over again. So it's kind of like to see if your model's on the right track in terms of what you want it to do, and then it's ready for testing. So you go to the final model and you test your data set on real world data or real world scenarios. So these are just some of the challenges you might face when building a machine learning model. There are 3 of them. I only covered 3 because it's really basic. But yeah. So you have what you call overfitting. So when a model is too complex and it fits the training data set too closely, which means you can't really use it to predict new things on a new data set. It means it's too aligned with the data set you trained it with. Then you have underfitting, when the model's too simple and it doesn't capture its underlying patterns, but it's also not good. It's not good for training or for the new data set you test it on. And then we also have bias, which I was surprised you actually get this, but yeah. So bias is when the model's predictions are just systematically off, and the training data itself is biased, or the model itself is being biased. So those are some of the challenges that you might need to look out for when you're building your machine learning model. Oh, I have a small video to play. So this is the Teachable Machine. It's a web-based tool. It was created by Google. It helps you to create machine learning models, really basic, something really simple for someone just looking to start. Or if you just want to explore, you can use it as well. So the nice thing about the Teachable Machine is you can create machine learning models in the Teachable Machine, export it, and use it in the kind of apps that you're building. You don't want to go through all the trouble to maybe do all the code, and it's got a perfectly good machine image detector or image recognizer, then you can download it, export it, and use it in an actual application. So I'm just going to play this video.
People are training computers and creating machine learning models to explore all kinds of new ideas. New ways to interact.
Yes.
To understand the world. To play. And experiment. But machine learning is pretty intimidating to get into. So we've been wondering, what if it wasn't? With Teachable Machine, we set out to make it easier for anyone to create machine learning models without needing to write any machine learning code. When it first launched in 2017, it allowed everyone to get a feeling for what machine learning is all about. But now, Teachable Machine puts the power of machine learning in your hands, allowing you to save your models and use them in your own projects.
So let's say you want to build a model to recognize you versus your dog. You just open up the site, record samples of you, and samples of your dog. Click Train, and you instantly have your own machine learning model, which you can use in your sites, apps, and more. You can upload your model to host it online, or download it to work entirely on device.
With Teachable Machine, you can create custom models for all sorts of things. Using images, audio, or even poses. Personalized machine learning models for the things that matter to you. And folks have already been trying it out, using Teachable Machine in their own experiments, solving problems in their communities, or even just at home. Start creating and see where your ideas take you at g.co/Teachable Machine.
Yeah, so that's just a small video about the Teachable Machine. Yeah. So the Teachable Machine is a web-based tool, so it's easy to use, it's easily accessible, and it was created by Google in 2017. It helps users to create machine learning models that are quick and easy. So if you just want to use an easy recognition, image recognition tool, and you want it to be implanted on a mobile phone, then it's easy to export this model and put it in an application, then instead of building the whole machine learning code. You don't need any experience and knowledge to use it. It's quite beginner friendly, it's really nice to use, and you can train your data or train your models by uploading images, sound, and or other data, and you can label them. Oh, and then there are 3 different types of tools that the Teachable Machine offers. So you can build an image classifier or a sound classifier and a pose estimator as seen in the video. The trained models can be exported and integrated into various projects, and such as mobile apps, as I mentioned, and websites. You can also integrate with web, and it's easily accessible, user-friendly, and it's easy for anyone to use. I think that's the beauty of it.
Is it only for supervised training?
I think at the moment, yes. There's different options. You can build a standard model or advanced model. And I think in the advanced model, you might be able to stipulate if you want non-labeled data. So this is just how it works. It's really simple. So you gather your data set, you put it into the class 1, class 2, you train your model, and then you can also test it. I'm going to go to that now. And then you can export it like the video said. So I created like a demo of what I did. I just created a small little project about dogs and puppies. And yeah, this is my demo video. So as you can see, this app is kind of really easy to use and it's really nice to use. So on the left are the data sets or data that you upload that you're going to train your model on and that you want your model to recognize. And then on top of it, on top of each little block when you upload your data set, you give it a label. So you want the model to recognize that these images here are golden retrievers. Or something that looks similar to that will have so much percentage of golden retriever in them. So I have uploaded 4 data sets. Golden retrievers, huskies, Dalmatians, puppies, and I trained the model. This is a previous project. And we're going to test some images to see what the model says about these images. So this model detects this image to be 100% a Dalmatian, which makes sense because I have lots of images of Dalmatian, and one of them probably really matches one of those dogs inside, and then they categorize it as 100% Dalmatian. Even though it's a puppy, it should have some percentage of puppy, but obviously, this obviously matches something exactly within the data set. And then I have another image that's outside of the data set that I trained, which is this Dachshund puppy. So now now this model recognizes that this picture is 74% of a puppy, which means it's small in stature, and it's got small ears, and it's got a small face, and it's got a small nose, and it recognizes that majority of the sorry, unfortunately my video is not working, but basically what I tried to do is I tested the Dalmatian image and it gave me 100% Dalmatian. And I was trying to figure out why, which was my first explanation. And then I tried something out of the dataset that I used to train it. And I wanted to see what features would pop up in this image. So I think due to the color of the Dachshund, it resembles closest to the golden retriever, which makes sense why there is a percentage of golden retriever in it. And it's small, so that's why it's got a larger percent of puppy. And the reason for the percentage of Dalmatian is actually because of its ears and how its face is shaped is very similar to how the Dalmatian looks. So it was really interesting to discover how it has not even seen this image before, was not trained on this data set, and it was able to categorize it based on what it has seen. So thank you very much.
Yeah, sorry, I want to ask, does this also support inheritance? Like you could put a Dalmatian and a puppy at the same time? Like something could be a Dalmatian and a puppy, like in your first example. Hi.
Yes, I think it does, but I think the data set that I chose was quite small, so it doesn't fully recognize that it's like 50% Dalmatian, 40% puppy, if that makes sense. So I think if I had to maybe categorize it better and then give it a larger quality data set, then it would work, yeah.
Thanks.
This actually looks very good. So my question that I had is, if I was to use this, in my own personal app. Hi. So I was saying this looks very interesting. So my question that I had is, if I was to use this in my own personal app or whatever, I guess the biggest worry I have is the data that is being used. Does it now become stored in my application data set, or does it get sent to Google as data so that it can be used to train other models?
Okay, I'm going to try my best to answer that question. think, to my understanding, when you download the model, then you download all the data sets that's within it, and then, it can be transported into TensorFlow, so then you can create a database with pandas and install the images in there for your app. I hope that answers your question.
Yeah, that's actually right. You can actually use it locally. So if you have worries about your data being leaked or breached or anything like that, you can actually use it locally or use it with one of the cloud providers, which are actually quite secure. So yeah. We have space for one more question, and then after that we can just have like a 5-minute grab and drinks refill. Any more questions? Okay, cool. Thank you, Jessica. This is really amazing.